expression for vector E due to an infinitely thin plane sheet. Infinitely thin plane sheet means this is our infinitely thin plane sheet. That means a size is very large. Size of the sheet is very large compared to the thickness of the sheet. Okay, and I'm taking a part of that infinite sheet. That is why dotted line here extending up to infinity. To determine field intensity due to this infinite sheet, you consider a point P at a straight separation R from this sheet. Okay, and same as previous derivation, we have to imagine a Gaussian surface. Here we have a Gaussian cylinder of length 2r, r plus r, 2r, penetrating the sheet in such a way that half the length of cylinder lies right side of the sheet and half the length lies left side or behind the sheet. Okay, and our point P lies over the cross section of this cross section. I took it as second surface, second cross section of this cylinder. Okay, and here also you can see one cross section, that is first surface, and curved surface area I took as third surface. Okay, now this Gaussian cylinder, this is our imaginary cylinder. When you draw figure, you draw the cylinder by dotted line. Okay, then applying Gauss's law. What is our Gauss's law? Integral. Here also closed notation is there. Closed integral. Closed sign is required. Okay, closed integral E dot vector ds. Vector E dot vector ds equal to q by epsilon 0. Okay, integral over the integral sign put circle, that is closed integral. Okay, applying this, same as previous derivation, you take LHS and split that into the sum of three terms. What are the three terms? Integral over the first surface means first cross section, E dot vector E dot ds. Integral over the second surface, that is second cross section, vector E dot ds. And integral over the third surface, vector E dot vector ds, that is our curved surface area. LHS becomes the sum of three terms, three surface integrals, integral over the first surface, plus integral over the second surface, plus integral over the third surface. Okay, then you find, let it be equation to find these values separately. Integral over the first surface, vector E dot vector ds is equal to E ds cos 0, because over the cross section, vector E and n cap, or vector E and vector ds are acting along the same direction. This cross section also, vector E and vector ds are acting in the same direction. And over the curved surface, vector E is perpendicular to n cap. Vector E is acting towards right. Arrow mark is towards left, you put towards right. Arrow mark towards right, and the n cap or vector D is perpendicular to each other over the curved surface area. Applying that conditions, and you can find separately the values. First cross section or first surface, EDS becomes E into integral ds. Integral ds is S, the total surface area of cross section, cross sectional area, that is S, taken as S, E into S. Similarly, over the second cross section, this is our second cross section, vector E dot vector ds equal to integral E ds cos 0. Cos 0, angle between E and vector ds equal to 0. N cap, you can see n cap, in the direction of n cap, vector ds is acting. Therefore, that also becomes E into S. Reason is here, E vector is parallel to n cap. Parallel means acting along the same direction of n cap. Okay, then the third surface, vector E dot vector ds of the third surface becomes E ds cos 90 because of the curved surface area, vector E is perpendicular to vector ds. The value becomes 0. Substituting same as previous derivation 3, 4 equations 3, 4 and 5 in equation 2. LHS relation. LHS becomes ES plus ES plus 0. First two values ES and the third value is 0. The value becomes 2ES. Okay. Then charge enclosed by this Gaussian cylinder is equal to surface charge density sigma. Sigma is the surface charge density, that into surface area. When you substitute surface area, you consider only the area enclosed by this area of sheet enclosed by the cylinder, that is equal to cross-sectional area. Correct? Area of the sheet enclosed by the cylinder is cross-sectional area. Substituting that value, we get Q is equal to sigma S. Substituting equation 6 and 7 in equation 1, 2ES equal to sigma S by epsilon 0. You can cancel S and S. Next relation becomes E is equal to sigma by 2 epsilon 0, or in vector form, vector E equal to sigma by 2 epsilon 0 into n cap.